Hi there. My name is Zhang, and I'm a PhD student in the NLP North group at the IT University of Copenhagen. And today I'll be presenting joint work with Christian Noga Jensen and Barbara Plank about de-identification of privacy-related entities in job postings. So, first of all, what is de-identification? How we define de-identification is that to remove entities that can identify persons or companies, to make the re-identification of such entities harder to comply to the GDPR regulations. So a small note about companies here is that company names usually are not part of the GDPR regulations. However, if the company names contain legal names, for example, Christian Jensen's Bakery, then we have to de-identify the company name. Another example below, founded by Brandon Beck and Mark Merrill, and currently under the leadership of CEO Nicole Laurent, were headquartered in Los Angeles, California. After the de-identification process, this would be founded by name, and currently under the leadership of CEO name, were headquartered in location. So, what is our motivation here? So, de identification has mostly been applied in the medical domain, where they would usually de identify electronic health records or electronic person records, where these records usually contain a patient's name and their information about either contact information or, for example, the illnesses. However, personal data is not only limited to this domain. For example, job postings, where job postings could uh, contain names of a recruiter, their contact information, the company's addresses, or other person names with their respective professions. So we do have another example here, name of a company and their address. And this would then, after the de-identification process, be organization and location. Then our research questions. How do transformer-based models compare to LSTM-based models on this task? So in the de-identification task in the medical domain are were usually dominated by LSTMs. But as we are now talking about the NLP field, um, we frequently use transformer-based models, and therefore, how do they compare to each other? Since they can also do, since de-identification is a entity recognition task, they can do that both. How do they compare to each other? Secondly, how does bird base compare to a domain-specific bird? So in this case, we specifically mean the embeddings, so bird-based embeddings, and the domain-specific bird overflow embeddings. I'll talk about the details later. So how would they compare to each other? Then third, to what extent can we use auxiliary data to improve de-identification performance? So it is known that a related benefit of multitask learning could be the transfer of learned knowledge between closely related tasks, which then could improve performance. Onto our setup. So we introduce a job stack where we annotated 395 job postings from Stack Overflow with five entities, namely location, organization, profession, contact, and name. For the experiments, we have a time-based data split where our training set consists of the job postings posted between June and August 2020, which would be 313 job postings. And then for our development and test set, we take the job postings posted in September 2020, which would then both result in 41 each. For the annotation process, we had 3 annotators, and below you can see their respective pairwise cohens kappa and the flies kappa. In this work, we're comparing 2 models, a BiLSTM sequence tagger, namely BILTI by Planke and colleagues, and a transformer-based model from the Machamp toolkit by Van der Gode and et al. And both of the models are with and without a CRF layer. And in addition to that, we also compare different BERT embeddings, namely the regular vanilla BERT-based embeddings, and a domain-specific BERT overflow, which is based on BERT base, and it is pre-trained on the Q&A section of Stack Overflow. Then onto the results. Transformer-based models versus a BiLSTM, and then the BERT-based embeddings versus the BERT overflow embeddings. We show our results on the development set, where we use the BiLSTM model with BERT-based embeddings or BERT overflow embeddings, and with and without a CRF layer. And similarly for the transformer model. We show that the BiLSTM model with the BERT-based embeddings and a CRF layer achieves the highest precision, and the transformer-based model with BERT-based embeddings and a CRF layer achieves the highest F1 score and recall. In general, we found that a CRF layer is helpful for high performance. Then for our third research question about auxiliary data. Since both models are capable of multitask learning, we have 2 auxiliary tasks, namely CONL, which is this general named entity recognition task of organization, name, and persons. And the I2B2 dataset, which is the electronic health records dataset, which is a electronic health record dataset, where it consists of patient records. We again compare both models, and we see that the transformer-based models with BERT-based embeddings and a CRF layer performs best. However, the performance differ between whether you use the CONL task as an additional task or the I2B2 dataset, where CONL would achieve the highest F1 score and recall, but with the I2B2 dataset, in addition to our job stack dataset, achieves the highest precision. Then our results on tests. So we use the best performing models of both the BiLSTM and the transformer-based model, so with BERT-based embeddings and a CRF layer, and also auxiliary tasks. And we see a similar trend in comparison with DEF, where the BiLSTM-based model achieves the highest precision with just the job stack dataset, and Machamp with BERT-based and a CRF layer achieves the highest performance regarding F1 score with the job stack and I2B2 combined. And then when you combine all the datasets together, you achieve the highest recall. So here we show that auxiliary data helps improving de-identification performance. So, and another question could be, do we need a CRF layer? So we found that the transformer-based model with BERT-based embeddings and without a CRF layer actually adds an I tag following an O tag 8 out of 426 gold entities. So when you have the bio tags, you usually start with a B instead of an I. And then after the B, you usually can only have an I or an O. We also did a per entity analysis on the test set, where we would compare the two auxiliary tasks. So with Connell and I2B2, and we hypothesized that I2B2 would be beneficial for contact and profession, and Connell would be beneficial for occasion, organization, and name, because that's what both tasks are about. We see that the I2B2 dataset is beneficial for profession, as we expected, however, not so much with contact. And in addition, Connell actually is not as impactful as expected. This could be due to the little amount of gold entities that we have in contact and name, and that could differ in performance heavily when you are missing one, or when you are mislabeling one. Then on to our conclusions. So here we introduced a new dataset called JobStack, containing 395 annotated job postings from Stack Overflow. Then for our first research question, transformer-based models versus a BiLSTM model. On the de-identification task, we see that a transformer-based model outperforms the BiLSTM model. Then BERT-based versus the domain-specific BERT overflow embeddings. So the domain-specific BERT overflow is outperformed by the BERT-based embeddings, and we think this is because the BERT overflow embeddings are pre-trained on the Q&A section of Stack Overflow instead of the job postings. So the language used is different. Then for the auxiliary tasks, we see that using auxiliary data helps improve de-identification performance. Thank you for listening. So for the code and the data, you can contact us, or you can go to the GitHub page by Christian. And then we hope to see you at the Q&A.